Welcome to the Residential Requirements for the 2006 International Energy Conservation Code training video brought to you by the U.S. Department of Energy. You now can receive .10 CEUs towards IECC renewal certification and/or 1.0 AIA CES learning units. However, in order to obtain AIA LUs, new AIA requirements dictated tests must be taken. At the end of this training video, you will be directed to a website to take the 10-question test, applicable to AIA members only. You must answer 8 of the 10 questions correctly in order to qualify for the 1.0 learning unit. BECP will report the AIA members who pass the test so credit can be awarded. A certificate of completion will also be available at the end of this training video.
Thank you. Today, the speakers are myself, Pam Cole, and Todd Taylor, both from the Pacific Northwest National Laboratory. So let's get started on the presentation of the residential requirements of the 2006 International Energy Conservation Code, again brought to you by U.S. Department of Energy Building Energy Codes Program. So a little intro into the IECC and how the whole family of I-codes work. IECC is just one part of the family of codes, and the IECC contains provisions for both residential and commercial buildings. It basically focuses on the minimum regulations for energy-efficient buildings using prescriptive and performance-related provisions.
Before we begin the details of the 2006 IECC, for the benefit of those of you who are familiar with the older version, the more recent or most recent 2003, we will briefly cover some of the primary differences between the old code and the new one. Probably the most important question that comes to mind has to do with stringency, but in that respect, the two codes are very, very similar. Any differences that do exist in terms of energy efficiency or stringency are relatively small, and they are local. The new code was designed to be roughly equivalent in terms of stringency to the old code, but because the format has changed significantly, there will be individual locations that are either a little bit tighter or a little bit looser than the prior code. Most of the differences, most of the things that are new in the 2006 IECC deal with the format. It is completely new. We don't have time here to cover all of it, but we will go over the primary differences, the things that you should expect as you're studying the new code. First and foremost, there is a completely new climate basis for the new code. The new code is based entirely on geographically defined zones. In other words, the zones are defined along county and state lines. There are no more dependencies directly on heating degree days or any other climate variable. This results in fewer overall zones, if you want to consider them zones. In other words, there's more homogeneity within jurisdictions and across jurisdictions that happen to be close to one another. In spite of the fewer zones, there is better climate coverage overall because the new zones are based on more than heating considerations. They consider a number of climate variables that involve cooling as well. And finally, commercial and residential sections of the code make use of exactly the same zones. That was sort of true before, but not entirely. If you recall the previous code, the primary requirements were defined as direct functions of heating degree days, and I've consolidated a number of those graphics here on this page. And any zones, when we talked about zones in the older code, those were really heating degree day ranges. They were not geographical zones at all. So if you look at the vertical dashed lines on this graphic, those are the breakpoints in those degree day ranges that defined the 19 zones, we called them in the previous code. And you'll notice that nowhere on that graphic between any two dashed lines are the requirements a constant. So in the previous code, the requirements varied continuously, both within zones and across zones. The new code is different in that everything is geographically based. Now, what I'm showing here on this graphic is the old code, the continuously varying requirements aggregated to county levels. So this is really more homogeneous than the code really was or is, but it illustrates just how much variability there is as you move from one location to another. Just as a quick example, you'll notice the state of Texas has 8 distinct climate zones in it in the older code. Now, if we look at the map for the new zones, you'll find there is much less variation as you move from one location to another. Texas, for example, is now down to 3 zones. Very quick explanation of the new zones. There are 8 temperature-oriented zones, roughly as you move from south to north. You don't see 8 anywhere on this graphic because it occurs only in Alaska. And those 8 zones are crossed with 3 moisture regimes: moist, dry, and marine. That gives you a theoretical total of 24 zones, but not all of those zones occur. If you'll notice the marine zone, that nowhere is zone 1 or 2 or 7 or 8. Nowhere do those occur in the marine regime. So there are fewer than 24 zones. I believe if you look at all the actual zones that occur in the United States, and then further consider that the code itself doesn't provide unique requirements in all of those that remain, there are something like 15 unique zones in the new code. A few other key differences in the format. First of all, single-family and multifamily have been consolidated. In the past, in particular the walls and windows section, there were quite different requirements owing to very different typical window-wall ratios in those 2 building types. That's no longer the case. And the primary reason, which is the second bullet down here, is that the envelope requirements of the 2006 IECC are completely independent of window-wall ratio. That's a big departure from the old way of doing things. No longer do your insulation requirements change as your window-wall ratio changes. That there is an exception in the performance path where you are able to account for some of the glazing considerations and so forth, but in the prescriptive section of the code, there are no more dependencies on window-wall ratio. The performance path is much cleaner, more complete, much more similar to the prescriptive path than it was in the past. Many of the ambiguities and uncertainties of the old performance path have been corrected. And finally, I believe it's important to note that complying additions, new portions of a house, is much easier and simpler now than it was in the past. That also owes to the decoupling of the envelope requirements from the window-wall ratio. A few other small but notable differences. There are some new hard limits. They're also called sometimes trade-off limits that have been added for glazing and U-factor, glazing, U-factor, and solar heat gain coefficient. What these are, these differ from the normal minimum requirement in that they are a separate requirement that you cannot exceed even in a trade-off situation. So you can back off on the code's baseline solar heat gain requirement, for example, but you can only go so far. Those trade-off limits did not exist in the older code. Duct R value cannot be traded off at all. That's a nuance in the new code that's worth noting. The prescriptive requirements are given in a new format and what I've called here purchasable units. Basically what we mean is the code expresses things in terms that you'll find on the package when you buy it. R value, not U factor, for example, for insulation. Finally, there is a requirement to seal the air handler, which was not there before. That is intended to reduce the total amount of air leakage in the duct system. It's something that can typically happen at the manufacturer, but it is a new requirement. Finally, let's summarize the overall relationship between the International Energy Conservation Code and the International Residential Code. This training deals with IECC, but you have to understand this relationship to really use even the IECC. The IECC, as its name suggests, addresses only energy, whereas the IRC is a consolidation of all the codes, structural, plumbing, etc. The intent of the IRC is to give builders a single book to carry around, and there's one chapter in there that deals with energy, Chapter 11. While the IECC addresses both residential and commercial, the IRC, of course, as its name implies, is only residential, and in fact it excludes most apartments. There is a reference from the IRC to the IECC, so generally if you're complying with the IRC, you may use the IECC. So there is a close relationship. It turns out that at least for now, in 2006, the energy requirements, the efficiency levels, the stringency of the two codes is very, very similar, almost identical. There are some minor differences. I mentioned the hard limits before. For fenestration U factor, those do not exist in the IRC, and there are different in the IRC, and they don't exist at all for solar heat gain coefficient. Pam?
Let's take a look at the new structure of the IECC for 2006. Now it's condensed to 6 chapters. The old 2003 actually had more chapters and consisted of over 100 pages or so. And now the 2006, I believe it's down to 60 pages or less. And how is it structured? The administration portion still sits in Chapter 1. Your definitions are in Chapter 2. Climate zones still remain in Chapter 3, but now Chapter 4 residential energy efficiency requirements are all in Chapter 4. And Chapter 5 is all the commercial provisions. In 2003, the commercial provisions actually sat in Chapter 8, and Chapter 7 was a reference to 90.1, ASHRAE 90.1. As Todd mentioned, here's a quick overview of the residential code requirements as they are in the IECC. The main focus in the 2006 is on the building envelope. Your ceilings, your walls, your windows, floors. It sets the insulation levels, the U factors and solar heat gain, infiltration control. And the ducts is only for ceiling and insulation. There's a lot of reference for your ducts over to the IRC as far as duct construction and so forth. And now the requirements are limited for space heating, air conditioning, and water heating requirements. Very limitations, a lot of mandatory requirements, because now the efficiencies are referenced right over to, because the federal law sets most of the equipment efficiency requirements, they are not in the I codes in the 2006. And as far as lighting and appliances, those are not part of the IECC residential code requirements. So the scope, in the scope of Chapter 1, for residential buildings. One significant difference here is that the IRC is for single-family, duplex, and townhomes. However, the IECC includes all low-rise residential, which includes your houses, your condos, and apartments, where the IRC does not include apartments. So it's broken down into R2, R3, R4, and what are those? Basically, the R2 is for occupancies that are containing more than 2 dwelling units. The R3 includes 1 and 2 family dwellings. And the R4 is for residential care and assisted living units. It does not include hotel motels, which are R1, which would throw you over to commercial requirements. So, buildings that are not designated as residential, how are they defined in the IECC? They would move over under the definition as a commercial building, whether it's a high-rise apartment complex or so forth, and that's where the limitation comes in. If it is greater than 3 stories, it falls under the commercial code. There are also some requirements for repairs, alterations, and additions. One example of that would be if you are putting storm windows, if you're installing storm windows over an existing fenestration, then you're exempt from meeting the requirements of the fenestration as though it was new construction. Another example of an alteration would be maybe you have construction where the existing roof or floor cavity is not exposed and you're doing some sort of alteration. If you're not exposing the cavity that has insulation in it, then that would fall under an exemption. There are several other ones that you can go out and look at in detail. Other exceptions, now these aren't for alterations, so to speak, but these are your major exceptions where you would not have to show compliance to the IECC. So if you have a building that has very low energy usage, which is less than 3.4 BTUs per square foot or 1 watts per square foot, then you'd fall under this exception. or buildings that are not heated or cooled at all. One example of that, if you had a garage that you're not heating, that's not occupied living space, well, the garage is exempt. You're not going to have to show compliance to that exterior portion of the garage wall. However, the interior side between the house and the garage, that's going to have to meet code requirements. Now, if you was to take the garage and make it into living space and you're heating and cooling it, then that becomes part of the requirements that would fall under residential, then you're going to have to show compliance for. Other buildings that are exempt would be your historic buildings that are on the National Registry and so forth. Some other new requirements to take in note here is that mixed-use buildings. Prior to the 2006, if you had like less than 10% of a minor occupancy and the rest of a different one, let's say if you had a commercial building and only 10% of it was residential, you would treat the whole thing as commercial. Now the case is you have to treat them both separately. So now you will have two compliance reports that must be prepared and submitted separately. Or you can do it at the same time, but you have to break out that building and do each one separately, your residential portion and your commercial portion. But keep in mind, if you have a building that is greater than the 4 stories or greater than 3 stories, it would all be considered commercial. So in the IECC, what are the options for compliance? You have prescriptively, and the prescriptive, when I talk about prescriptive, and we'll get into some of these in detail, is it's an R-value table, as I call it. And you can go to this table, and you can look at your climate zone and fall under all the direction of what your maximum insulation levels will be, the maximum U factor, or I should say the minimum insulation levels, and maximum U factor and solar heat gain requirements are. The U factor or UA alternative is you can do some simple trade-offs for your total building UA approach. The U factor table is basically for some types of construction that might not fall under the R value table, where you're doing more maybe some design that wouldn't fall under the insulation levels that are called out in the R value table. And keep in mind when we're talking U factor and R value table, the R value table is for insulation only. The U factor table is for the entire component of the assembly. And over to the simulated performance approach. This is where you're going to use probably a piece of software, but you're doing the energy performance of the entire building and can receive credits for orientation and other things doing this approach, and we'll talk about that later. So your compliance tools, very important. On the prescriptive side, really none is needed. You're going to the R value table, you're making sure you're meeting the mandatory requirements, and you're done. The total building UA trade-off, this is where REScheck would come into play. And the 2006 IECC is being implemented into REScheck, and it's expected to be done later this year. No states have adopted the 2006 IECC yet, and we're working to make sure that this tool is ready once states start adopting this code. And this code will also be available in the web-based version of REScheck as well. We have a software desktop downloadable, and we also have a web-based version of REScheck. And as far as energy analysis, this is where REM design, REM rate, or energy gauge would come into play to show compliance to the performance criteria in the 2006. Now, climate specific. We're not talking the percentage of glazing anymore, but what happens there is that your stringency is different depending on your climate zone. But where is it different? For your foundations, your above-grade walls, your fenestration, your roofs, and then vapor retarders, there's also some climate specific in the solar heat gain. But there's universal requirements that do apply everywhere. That is your duct insulation and sealing, your infiltration controls. And again, as we're talking about climate specific, let's take a look at this map again. So if you are in climate zone 1, your insulation requirements are going to differ than if you are over here in Montana in climate zone 6. And it's pretty straightforward. You're looking at where you're at and going through and defining what is your criteria that you need to meet, and the mandatory requirements that we will discuss, they will also have to be met regardless of your climate location. So the first table is I call it the R value table, or in IECC, it's the insulation and fenestration requirements by component. And there is no percentage of glazing to determine what your requirements are. It's only based on the climate zone. So, for example, the wood frame requirements that fall here. a little bit of more information here as far as some of the things that are in here. If you're in Climate Zone 5, Marine 4 or 6, the 13 plus 5 means R13 cavity insulation plus R5 insulated sheathing. If structural sheathing covers 25% or less of the exterior, sheathing isn't required where the structural sheathing is used. So if structural sheathing covers more than 25% of the exterior, structural sheathing should be supplemented with insulated sheathing of at least an R2. R19, another thing to note, is R19 is allowed to be permitted into a 2x6 cavity. That means it can be compressed into a 2x6 cavity, not a 2x4, a 2x6. The basement wall and crawl space, this 10/13 over here, what does it mean? Well, the first R value applies to the continuous insulation, and the second one is to framing cavity insulation. Either insulation meets the requirement. This is not a 13 plus. This is either or, 10 or 13 in this respect. Now on the slabs, if you have a heated slab, no matter what climate zone you are in, you have to add an additional R5 to the slab edge. So if you have 0 sitting here, you are still required to add R5. So this would apply to all climate zones. And then again, what you don't see on this table is the solar heat gain requirements. There are no solar heat gain requirements in the marine zones. So the U factor and total UA. We've looked at the R value prescriptive. Now let's go over to this other compliance approach, which is the U factor total UA. Now the U factor table, again, is for the entire assembly. This is not your insulation values anymore. And this is where it allows for innovative or less common construction techniques, such as structurally insulated panels or the log walls. You might be thrown over or be looking at this U factor table, especially for log wall homes, instead of the R value table. If you're not insulating your log walls, then you are going to be looking at the maximum U factors. And then the total UA alternative. And it's the same as the U factor alternative, but allows for some simple trade-offs, which we call REScheck. So if the total building envelope, or the thermal envelope, I should say, the UA, which is the sum of the U factor times the assembly area, is less than or equal to the total UA resulting from using the U factor table in 402.1.3 multiplied by this same area as in a proposed building, then the building would be considered in compliance. Now, one thing this table does not have is that the solar heat gain requirements must be met in addition to the UA compliance. So on the U factor table, you're not going to see the solar heat gain. You still have to go over to the R value table for the solar heat gain requirements. But again, they're all based on climate zone. And they start out with fenestration and go over to skylights, ceilings, and so forth. And we're going to look at these in detail in the order that are given here and give some more information as far as fenestration, skylight, ceilings, and walls and so forth. So how does these specific requirements come into play? Well, you're basically defining the thermal building envelope. That is what you're looking at. As I discussed before about the garage, if the garage is not heated and cooled, it's not used for human occupancy, then the garage is not part of that thermal building envelope, but that wall and door into the house is part of your thermal building envelope. And that's what we're going to go over today is some requirements that are defined for your thermal building envelope. And let's start out with fenestration.
Thanks, Pam. Pam has gone over the general envelope requirements, and we're going to look at a few of the specific components now and get a little bit more detail. We'll start with fenestration. Fenestration is defined basically as windows and doors. That can be any door. It doesn't have to be a glass door. Any opaque door is considered fenestration. Something like a glass block wall is also considered fenestration. In complying with the fenestration requirements, your building must comply on an area-weighted average basis. In other words, it's okay to have some of your windows that fail to meet the minimum requirement in the table, as long as enough other windows in the home exceed those requirements so that the area weighted average comes out to meet the requirement in the table. Recall, as we mentioned earlier, there are some hard limits as you're doing trade-offs that you cannot exceed, and Pam will talk more about those in a moment. The windows that you use are required to be rated by the National Fenestration Rating Council. That's how you get the U factor and SHGC values that you'll use for compliance. There are some exceptions to that owing to carefully chosen default values and so forth, so such that, for example, in Zone 1, any unrated single-pane product is going to comply, and in Zones 2 and 3, there are similar provisions for double-pane glazing. To accommodate decorative glass, side lights on your doors, and that sort of thing, there's an allowance for a 15 square foot exemption of glazing in the prescriptive path. This is prescriptive path only, so that you can just completely ignore that in your compliance calculations, and it makes things easier when you're using that simplest compliance path. The solar heat gain coefficient requirement is required in zones 1 through 3, and the U factor requirement applies to all zones. Moving on to ceilings, the requirements differ by assembly type, meaning a ceiling underneath an attic has different requirements than a cathedralized ceiling, for example, a sloped ceiling right underneath the roof. We speak about the continuous insulation versus insulation between the framing. If you're using the R value table for compliance, those two are are considered to be identical. You simply add the R value that's between your ceiling joists to any R value that completely covers your ceiling joists to get your total thickness, and that's what you base requirements on. If you're using the U factor table, for example, in a UA trade-off approach, you do need to make proper accounting for the fact that the insulation between the framing members has a parallel heat flow path through those framing members, and you have to account for that in your calculations. The requirements related to ceilings and roofs assume that you have a standard roof truss system. As you can see in the graphic there, when the ceiling joists meet perfectly with the wall top plate at the same point, more or less, where the rafters come down, you end up with a small point, a small corner there that's very poorly insulated. The code assumes you're using that standard configuration, and the requirements are based on that assumption. If you use what we call an energy truss, sometimes a raised heel truss, that raises the rafters up enough such that you can get the full insulation thickness over those top plates, the code allows you to back off on the requirement for the thickness of the insulation. If the code normally would require R38, you can back off to 30. Where it requires R49, you can back off to 38 instead. Let's move on to above-grade walls. The above-grade walls that must be insulated are those that are next to either outdoor air or unconditioned spaces. For example, the wall between the building interior space and the garage is required to meet the same requirements as walls between the building and the outdoors. There are differing requirements for many different types: concrete block, concrete, insulated concrete form, things that we consider to be mass walls, log walls, and so forth have different requirements. When we look at mass walls, there are a couple of things to bear in mind. Because of the thermal benefit that the massive wall system has on cooling loads, typically you have lower R value requirements for the mass walls. However, there's a requirement that at least 50% of the required R value must be either on the outside of the wall or integral to the wall. What that means is if your insulation is on the inside of that massive wall, as the engineer would say, you have decoupled the mass from the interior space, and it doesn't give you the benefit. So you are required to fall back to the frame wall requirements if you don't have your insulation on the outside or integral. Now, an example of when that might happen, let's say you have a concrete block wall, and your plan is to finish the interior by furring in, and you intend to put insulation between the furring members and insulate on the inside. By decoupling the mass from the space, you cause yourself to revert to the frame wall requirements, and your R value for that wall would have to be equal to the requirements for a frame wall. There are some exceptions in zones 1 through 3, such that you don't have to back all the way off to the frame wall R value requirement. Sometimes you can only go part way, but that's the general principle. The insulation needs to be on the outside or integral with the massive parts of the wall. There are specific requirements for steel framed walls because of their unique thermal behavior. There's a special table, as you can see right here, and you would use that for any wall that uses steel framing. And the same is true for ceilings and floors as well. When we talk about floors over unconditioned space, the unconditioned space can be the outdoors, it can be an unheated basement, it can be a vented crawl space. Anything of that sort is subject to these requirements. The requirements are fairly straightforward. The first two zones are 13, in the middle of the country are 19, and beyond that are 30. There is a requirement that the insulation, when it is installed in the floor, be held firmly up against the subfloor at the top. So you can't let it hang down to the bottom of the members. You don't want an airspace above it, and that is part of the requirement in the code. Let's move over to below-grade walls. As before, in the older versions of the code, a wall is defined as below grade if more than 50% of it is below grade. And there is no requirement for insulation on those walls in the first two zones. Beyond that, there are requirements, and as Pam mentioned in the table, you can insulate either on the interior or the exterior, and the requirements are slightly different depending on which you choose. As I mentioned, defining the wall depends on the total area that's above or below grade. So for a walkout basement, even though you might consider that front wall part of your basement, so you might call it a basement wall, it's not a below grade wall, and it would have to comply with the above grade frame wall or mass wall provisions. The code does have requirements for slab edge insulation in some of the zones. You can see the requirements right here. There are requirements both on the R value that you must have in place and the depth or the total length of the insulation slab, or insulation on the slab. The total length requirement, which is 24 inches in zones 4 and 5, 48 inches above that. You can achieve that total distance either in a depth straight downward or in a horizontal direction. It can extend underneath the slab, or it can extend outward from the slab, which we don't have pictured, as long as it's appropriately protected with enough soil. The next graphic will show there is an allowance to cut the top of the insulation if you've insulated on the inside of the stem wall at a 45-degree angle. That makes it easier to attach nailing strips and such when you get the house completed. Crawl spaces, we've already talked about floor insulation over crawl spaces. If you have a conditioned crawl space, or something that's sometimes called an unvented crawl space, you insulate the crawl space walls rather than the floor above the crawl space. This makes for a very good system. It allows you to not only put piping and such in there so it won't freeze, but you can put your ductwork and even your HVAC system in that space and essentially move it to the inside of the conditioned space so that your losses from those ducts don't go outside. There are some differences when we talk about vented and unvented crawl spaces, as you can see here in the table. With a typical vented crawl space, It's an unconditioned crawl space. You insulate the floor overhead. There's a requirement for a vapor retarder, possibly, depending on where you are, in the floor system over that crawl space. And there are specific requirements for the amount of ventilation opening that exists around the edge of the crawl space itself. Any ductwork that occurs that is placed in that crawl space must be insulated to the R8 requirement. In contrast, an unvented crawl space, also known as a conditioned crawl space, you insulate around the edge. There's a requirement for a vapor retarder on the crawl space floor over the dirt because that's essentially a conditioned space, and you want to keep the moisture from the dirt out of the space. The insulation requirements on the crawl space wall are stated both in terms of the R value and how far down you must insulate. And you'll notice there's a requirement that it extends all the way down from the top of the wall and then horizontally across the floor, if necessary, a total of 24 inches. There is no requirement for your typical crawl space ventilation in this case, but there is a requirement that you either provide a little bit of conditioned air into that space or some mechanical ventilation through that space just to keep the air moving very slightly. And you can see the values in the code for that. Pamela's going to talk about additions now.
Okay, additions. Additions in the 2006 have really made it a lot easier. In the 2003 and prior, it has always been hard to meet compliance when you have an addition, because what are you doing with an addition? Basically, you are wanting those pretty windows and you're adding to your house, adding more fenestration. And sometimes you can fall under the sunroom criteria, but a lot of times you couldn't. And now the simplification that's happened in the 2006 is there's no percentage of glazing anymore. And that's where it came to be the hardest point to get an addition to meet code, was that percentage of glazing. Now you will treat that addition as though it's new construction, and you can go to the prescriptive table, either the R value table or the use factor table, and meet the criteria for the climate zone in which you're in, where you're building your addition. You still will have the same requirements for your fenestration. The solar heat gain still applies, the use factor still applies, but you're not targeted to that percentage of glazing anymore. So this should make it so much easier for building additions using the 2006 IECC. Now, there's still sunroom criteria, but something else has changed here. Again, you have less stringency for your R values, and your glazing, use factor, and solar heat gain still have to apply. But what defines the sunroom? It is where you do have a little bit of glazing, because there is a definition here. And that is where you have glazing that is greater than 40% of the gross exterior wall and roof area. And it has to be thermally isolated, so that common wall that might be open if you had an addition that you can walk to and from the space cannot be the case for a sunroom if you're falling under all this criteria. It's going to have to be thermally isolated. You're going to have to meet either the R value table or the use factor table. And it's going to have a door or a slider, so it's permanently thermally isolated from the other part of the existing part of the building. So what are the less stringency requirements on the sunroom? Well, for your ceiling requirements, they are a little bit different. So if you were looking over on the R value table, you're going to see that the stringency comes into play a little bit less stringent for your sunrooms, where in zones 1 through 4, it's R19. Wall insulation is another thing to look at, is that you now have a less stringency of R13. And as far as the solar heat gain, the prescriptive requirements, the solar heat gain requirements are applicable, and regardless of where you have your sunroom, what climate zone you're in, all the hard limits and any trade-off up to a certain point for certain climate zones still have to be used, and you still have to go to that use factor table. You're not going to see that there is some footnotes and other less stringency for the solar heat gain requirement. So let's take a look now. We're talking about mandatory requirements in the building envelope. What are they? And these are things that cannot be traded off no matter what compliance approach that you're doing, which is your air leakage, your recessed lighting, moisture control, and then the hard limits that were discussed a little bit in detail, which is your maximum fenestration on the U factor and solar heat gain. So let's take a look at these in more detail. Air leakage is pretty straightforward. Basically, anywhere there is a place that you can seal it, you must seal it. So around your windows and doors, make sure that they are sealed with a type of gasketing material, or if you're using sealing methods between dissimilar materials, you need to allow for the differential expansion and contraction of that material. So around all your plumbing is another area. And some more information on air leakage. Where is this? Well, what I want to get here, the point I want to make is there is one place that is a common place that gets missed when you are doing your air sealing, and that is behind the stairwells and exterior walls. The other one is your attic access hatches. If your attic access hatches is within the thermal building envelope, are you sealing it properly? And for inspectors, this is the most tedious task of going out and making sure that every place in the thermal building envelope that has a penetration where it should be sealed properly is being done. And this is where you have a building official that will come out, and he might be marking every one of those, but it's up to the builder and whoever is doing the building to make sure you're properly sealing the building envelope. Recessed lighting fixtures. The type E IC rated or insulation contact and labeled in a sealed or gasketed enclosure. You're also going to have type IC rated and labeled that meets the ASTM E283 requirements, that has no more than 2.0 CFM of air movement. But then there's also another requirement if you don't have a type IC rated can, that if it's located inside an airtight box with clearances of at least 0.5 inches from any combustible material and any insulation, 3 inches from any insulation contact as well. Now, vapor retarders. When I talked a little bit before where it was climate-specific requirements, vapor retarders does somewhat fall under mandatory requirements because you can't trade it off, but it's based on a climate location. So if you're in the climate location that requires you have one, then there is no trading off. It's mandatory. So that's why I had it under the bullets of specific climate requirements. Now, what are the requirements? What are you doing? You are installing the vapor retarder. Typically, you're installing it on the warm and winter side of the insulation. And this is in unvented framed walls, ceilings, and floors. And here's a picture of where the vapor retarder typically sits. Exceptions to that is where you have construction where moisture or freezing won't damage the materials, or if there's another proven means to avoid the condensation, then you would fall under that exception as well. Where does another exception fall? Basically, the code official has the final authority of the type of construction components and what you're using in that building. And therefore, if you don't fall under one of these requirements and you're in a climate location that requires a vapor retarder, then that's where you're going to go to your code official to discuss it further. So here's a visual of where the vapor retarders are in the climate locations. And typically, it's not in your, your warmer climates down here, your Texas and Florida areas. Window U factor. This is where the strict limits come into play in your northern regions. So, U factor of 0.48 is the maximum in zones 4 and 5. And U factor of 0.40 or less is the maximum in zones 6 and 8. The maximum means that this is in the mandatory requirements. No matter what approach you are doing, it's required that you can't go over it. And the skylights is the same thing. You have a maximum of 0.75 as well. For the solar heat gain, the strict limits on the solar heat gain, 0.40 or lower is required in your southern climates. And this is based on an area weighted average. You can't trade this off. This is what is the maximum. So what you can do is a little bit of trade-off, You cannot exceed 0.50, even if you're doing the performance path or trade-off, using the area weighted average in those climate zones of 1 through 3. This is a maximum. This is no trade-off. It cannot exceed 0.50 in climate zones 1 through 3, no matter what approach you're doing. So a visual of where the solar heat gain requirements come in. It's kind of the opposite of what I was talking about for the vapor retarder, but now you got a solar heat gain requirement, which is on your fenestration, which is down in your southern locations. And let's now jump over there and talk about the mandatory requirements that sit in the IECC. Let's go into the mechanical and some mandatory requirements and so forth on the mechanical system side. Todd?
Mechanical requirements in the code are largely preempted by federal law. The National Appliance Energy Conservation Act of, I believe, it was 1987, preemptively regulates the efficiency requirements of most residential style equipment. One of note that you've probably heard about, the minimum allowable manufacturing standard for air conditioner efficiencies has recently changed from a SEER of 10 to a SEER of 13. That really has nothing to do with the I codes, except that the I codes do specifically make reference to those federal minimums as the baseline efficiency requirements in your trade-off path, your performance path. But there are some other requirements related to mechanical that are in the code, typically related to mandatory things that you can't trade away. You see the list here. We'll talk about a few of them in detail. Let's talk first about ducts. There is a requirement that ductwork be insulated to a level of R8 anywhere outside the building envelope. There is one exception for ductwork that you fit within floor trusses. Now, that's not using the floor truss itself as a duct cavity. That's placing the duct within that floor cavity. You're only required to insulate those ducts to R6. It's, as I mentioned earlier, you should remember and bear in mind that these are mandatory requirements. You cannot trade these off. There are also some specific requirements for how you seal the ductwork, and those requirements are taken from the IRC in the section shown. Piping insulation. There is a simple, straightforward requirement of R2 on basically all HVAC and circulating hot water piping. There is an exception for HVAC systems that would be conveying fluids between 55 and 105 degrees Fahrenheit. But anything that's carrying chilled water, which is going to be typically below 55, or warm water for heating above 105 is required to have the R2 insulation. There are specific requirements for ventilation in the code for outdoor intakes and exhaust. It must have automatic gravity dampers and so forth. When you install those, there are specific requirements for sizing your equipment properly. Those are taken from the IRC in the section noted. You must conduct those load calculations to compute the appropriate size. That may seem like an odd requirement in an energy code, but it's important to get the equipment sized correctly in order for it to operate efficiently and operate the way it's supposed to. Pam?
Compliance, documentation, and inspections. I talked a little bit about inspections as far as air sealing, but let's look at some of the things that are important, or that I pointed out that are important to take a look at if you're reviewing the code. As I mentioned before, the code official has the final authority as far as the software, the worksheets, and any above code programs or software applications on the performance side that he has the authority to approve or disapprove. Also in the code, what's new is wording that has in there for electronic media can now be used. And again, it's up to the discretion of the code official for what type of electronic media can be used. Such as an example of that would be the REScheck tools. You could submit your report electronically right from within those tools, whether it's the desktop version or the web-based. When you're done with your compliance, it passes, you save it. You'll get to a screen on each one of them, and it'll say, do you want to submit this electronically right to the building official? And if they have a means to do that, then in the code, it's just addressing it not in detail, but you can do it by means of electronic. And construction work, this is not new, but construction work where a permit is required is subject to inspection. Now, this means that if you're doing new construction and you need to call for a permit, then be under the basis that they're going to go out there and inspect the work and make sure you're meeting the requirements of the IECC. That's if that is a code that's within your jurisdiction or within your state. One thing I want to talk about, though, what's new and I think is really nice that's now in the code is a certificate is required. So what does that certificate mean? This is a certificate that we're actually going to incorporate into our REScheck tools. So you can print out this certificate after you do your compliance and you got your compliance report and inspection checklist. It'll be a page or so, depending on how we get this all on all the information that's needed on the certificate from the code. And you could print that out on an adhesive label, like an Avery label. So where does it go? It has to be permanently posted on the electrical distribution panel. And what does it need to include that comes from the wording in the IECC? The R values of the insulation installed for the thermal building envelope, that includes ducts outside the conditioned spaces. All the U factors for fenestration must be on this label or certificate. Your solar heat gain must be on there. Your HVAC efficiencies and your service water heating equipment. Now that I've talked about certificates, there's one approach that we really haven't got into detail, but it has, in the 2006 IECC, it has made it as far as more clear as to what is required in the simulated performance approach that Todd's going to discuss.
Thank you, Pam. The simulated performance approach has changed a lot from the previous code. The previous code, if you were familiar with that at all, was fairly difficult to understand. The new approach is very, very clear, very straightforward. There's a very simple 2-column table that lists the requirements for any simulated building analysis that you do, both for a standard baseline home and for your proposed home. Typically, you're going to use software to comply with this route, and in fact, the code itself has particular requirements for that software, what capabilities it must have. There is a provision in the code that allows the local official to approve other tools that don't necessarily follow the requirements for the software capabilities, in the event that there is a local program or a local tool available that the code official might want to be able to use, even if it doesn't contain all the capabilities. It could be used for homes that don't require the more extensive capabilities. This path is the only path you can use to do trade-offs with equipment. It's the only path you can use to do trade-offs with solar heat gain coefficient. So it allows a general trading of energy efficiency among envelope, equipment, solar heat gain coefficient, and it even allows you to take account for certain things that the prescriptive portion of the code doesn't regulate at all. For example, favorable orientation, exterior shading, and that sort of a thing. It also has an approach in there that will allow you to take credit for specifically tested type ductwork. If you have done an extra good job of sealing your ducts and you have a test to prove it, you can take credit for that in the performance path. This path, as I mentioned, lays out the specific ground rules for the simulation. What do you assume for various inputs that are not part of the code's requirements? Those are all in this section. They are typically going to be hidden in the compliance software, and you won't need to worry about them. If you are interested, they are very, very similar to the ground rules that appear in, for example, Energy Star home guidelines, the requirements for federal tax credits, and the most common home energy rating systems that are out there. Pam?
Okay, now to our website, energycodes.gov, and the email for where you could submit additional questions, or if you have something that you want to ask later on that you couldn't remember during this broadcast, submit it through tech support at becp.pnl.gov. REScheck, again, is currently being implemented. We're going to get the 2006 IECC in there. Now, I've mentioned that no states have currently completely adopted the entire state, the 2006 IECC. There are certain jurisdictions that have already gone forward that are showing compliance to it. So where can you go if you're not sure what's happening within your state? Go out to our website. On the left-hand navigational pane, there's a status of state codes. Click on that status of state codes, go out and click on the state of your location, and see what the current status of your code and whether REScheck and or for commercial ComCheck can be used within your state. There's also other advocacy groups out there that pay attention to what's happening within the state. Are they going to adopt a certain code, such as BECP? You could go out to their site and look to see, well, I know what this code is, but are they actively doing anything? And BECP can give you that information because they're an advocacy group that actually goes out and pays attention to what's actively going on. Are they in the process of adopting or reviewing a certain code? Also on our website, if you haven't signed up for the Setting a Standard newsletter, do so. Register online. You can get an electronic version of it, or you can get a hard copy. But this is where we have a quarterly newsletter that goes out, and it will actually have information that's relating to certain activities within the state or certain code things that have happened, such as the new minimum efficiencies that have changed. That was in our last newsletter that you can go out there and read right now. It's out on our website. And other things that are maybe might be tedious that's out in the field, that we'll have in the field articles, such as the one that's shown here for basements. That's always been a difficult one as far as when you're defining your basement, whether it's conditioned or unconditioned, and how do you show compliance to it. Again, if you have questions and comments, there's two avenues to do that. I gave you the tech support email that you can take down. And then if you forget that or you don't write it down, if you go out to our website, there is a help desk online electronic form that you can go to, fill out your name, and submit your question that way, and they come right in, and we will answer them. That ends this portion of training or giving you residential requirements on the 2006 IECC, brought to you by U.S. Department of Energy Building Energy Codes Program. Thank you for attending our session today.
This ends the training video. If you would like to take the test to receive AIA credit and or print a certificate of completion, please write down the URL shown on the screen. You will need to type this URL into your internet browser. Thank you.